In this video, we're going to talk about the applications of the ideal gas law. And a couple of applications we should look at is the idea of molar volume. And we're going to look at molar mass slash density, okay? So the molar volume happens to be the volume occupied by 1 mole of any gas at SP. So it has to be 1 mole of any gas. So 1 mole of any gas at SPT, you're going to see the special number here. Okay, and so what does STP stands for? Standard temperature and pressure, where the temperature is 0 degrees Celsius, or that in kelvins would be 273.15 kelvins. Okay, and the pressure is just 1.0 atm. Okay, so the question is, well, what would be the molar volume of 1 mole of any gas at STP, standard temperature and pressure? Well, we know that PV is equal to nRT. The molar volume, so we're solving for V here, so therefore V has to be nRT divided by P, and then I'm just going to simply plug in. Okay, so the number of moles, well, that's just 1, so this is 1.00 mole. What is R? Well, that's the ideal gas constant, so that is 0.08206 liters per atmosphere, moles per Kelvin. Okay, the temperature, as we said, we got to convert the temperatures to Kelvin. You got to remember that, okay? And so this would be 273.15 Kelvin. Okay, and the pressure, as we said, was just 1.0 atm. Okay, and simply when we plug all this into our calculator, we should get around 22.4 liters. Okay, so this is the answer. So the molar volume for any gas, the molar volume of 1 mole of any gas at STP happens to be 22.4 liters. So that's special. But remember, it has to be 1 mole. You know, if it's 2 or something else, that would drastically change our answer. Okay. Now we can talk about the density of a gas. Okay. And we use density in this type in the ideal gas constant, ideal gas laws to find, you know, molar mass in other applications. So we should know that the density is given by pressure times the molar mass divided by R divided by T times T. And so I have this problem here. It says a gas has a density of 1.43 grams per liter at 23 degrees Celsius and 0.789 atm. Calculate the molar mass. Okay, so we know that D, the density, is equal to pressure times the molar mass, and that is divided by RT. Okay, so therefore it's out for the molar mass. So if I multiply by RT on both sides, then I get DRT. I get DRT is equal to the pressure times the molar mass. Okay, and then if I divide by P, then I get my molar mass to be equal to DRT divided by P. Okay, and this simply becomes a plug-in in question. So my density happens to be 1.43 grams per liter. And we multiply that by R, which is the ideal gas constant, 0.8206 liters per atmosphere, moles per Kelvin. Okay, we know the temperature. Well, it has to be converted into Kelvin, okay? And so we know 273.15 plus 23, that will give us the temperature in Kelvin. So that happens to be 296.15 kelvins. Okay, we're just simply divide that by the pressure, which happens to be 0.786 atm. Okay, and so with that being said, we're gonna plug in all that in our calculator, and we should get around 44.06 grams per mole. Okay, so again, what does this correspond to? Well, if you look at this is actually carbon dioxide, so this is CO2. Okay, this molar mass is CO2. So this is how we would find the molar mass of any gas. You know, using this formula here. So this formula is very important, and we could go on and do multiple problems. But these are the applications of the ideal gas law and what we could use this beautiful equation to do.